Hello everyone, welcome to the second lecture in C. And today we'll be looking at the build phases in C, as well as we'll tackle our previous example. And this is where we left off. We have just printed hello world in the screen, but we didn't know how it got printed in the screen. We don't know what this line actually does, what this line does, what this print statement does, what return statement does. So before diving into that, we should know what a function is in C, right? What is a C function? So let's get started with that. As you can see here, I've created a machine, and let's say this machine takes an input, does something, and returns an output, right? And in C, function behaves similar to this machine. So we can say that a function in C is like a machine that does something for you. So it's not necessary for a machine to take an input. It can do the default task that it has been assigned to do. And similarly, for a function in C, it's not necessary for a function to take an input. So it can just do its default task, right? And to write a function in C, we should first write its return type. It can be of any type, as integer and or a void or a character or user defined types. We'll look at this in the future videos, but now just bear with me and just write integer over here and a function name and small bracket with the opening curly braces, and inside of those curly braces we'll write function body. Whatever the task that the function is being assigned to do, we'll write those. Now let's see the previous example, and we can see that this right here, this block of code is a function because it has a return type as an integer, that is int. This is the first one, and the name of the function, which is main, and a small bracket and the opening and the closing of the curly braces, and inside of those there is a task that it has been assigned to do, and the task is to print hello world, right? This is a statement, and this is also a function if you look if you look clearly, and we'll discuss this in future videos as well, because this is a different type. You are just calling a function over here and passing the input, but in this function you are not passing the input, you are just doing the default task. And in C, main is a special type of a function because whatever you write inside of the main function gets executed first. Basically, you can say that main is the entry point in your C code, and to prove this point, I'll edit our previous code, and this time I'll create a function over here, and I'll use void as a return type. And if you use void as a return type, you don't have to specify return statement like here, and you can write your own custom name for a function name, and opening and closing of a small bracket, then opening and closing of a curly bracket, and whatever you write inside of this curly bracket is the task that this function has to perform. And this time this function will perform printing task, and it should print hello coders. So if you look at this example, then you can say that if the main executes first, then the hello world will be printing first, and then the hello coders, right? Let's see what will happen. Let's compile and let's run this code. As you can see, only the hello world gets printed. And why is that? That's because you didn't call the function, because the machine, the display machine, did not even get started. In programming term or in programming terminology, you can say that the display function was not called. And to call a function or to start a machine, what you have to do is you have to specify the function name and the small brackets and in with a semicolon, because it's a statement and every statement in C ends with a semicolon. Now you compile and again run this file. Now you can see that hello world and hello coders was printed in the terminal. Now let's see the flow of execution of that code. At first, as I said, that the main function gets executed, right? So at first the hello world was printed because the printf function was called first, and then the display function was called and the hello coders was printed in the next line. And to print hello coders before or above than the hello world, you can specify display function just above the printf function. And to do that, you should just, okay, so this is not the file. The file that we wanted is this, and you can copy the calling of this function and you can paste it over the printf function, and you can save the file. Now compile the file and run it. Now you can see that the hello coders was printed first and then the hello world was printed. To print the hello world in the next line, what you can do is you can again edit our example and you can give a new line character inside of the print function and again compile the file and run the file. Now you can see hello coders was printed first and just below that hello world was printed. Now you may be wondering that where is the implementation of that printf function? As you can see, the display function was called over here and its actual implementation was just above the main function, right? But here is the actual implementation of this printf function, was just called over here, but its definition is nowhere to be found in this code. So where is the actual implementation? Where is the actual definition of this function? And this function is actually called a predefined function, which is inside the standard C library, which is called libc. Libc is the standard C library which has a bunch of predefined functions, and printf is one of those, so that you can use this function in your code. And the name and the signature of this function is present in the header file just above the display function, and this is what we call a header file. You are including this file so that you can use the printf function. This file does not have the actual implementation of the printf function, but it specifies that the actual implementation is present in the standard C library. That's the only job this header file does. You can also view the header file, and to do that, let's go to usr include, and you can see there is the standard input output.h. The stdio.h means the standard input output.h, and you can view this file vim stdio.h, and this is what you will see inside of this file. This is what you will see, and you can search for the printf function over here by typing extern, I think it's extern into printf. Okay, it's not searching. It may be somewhere around. Okay, right here, as you can see, the name, only the prototype, we call this a prototype. We'll learn more about function prototyping later chapters, but this is what we call mentioning the prototype of a function, and this header file says that the actual implementation is inside of the standard C library, so that you can use the printf function from there. And now we'll discuss about the build process in C and how the C source file, that is foster C, goes from the pre-processing phase to the linker phase and generates an executable file, that is a.out. We'll see each phases in detail, and we'll also view each files in detail. So at first I have deleted other files and only kept our source file, that is foster C. And this source file, when compiled, at first it goes to the pre-processing phase, where the preprocessor program copies the entire code of the header file into our source file. If you see this file, we have used the header file, that is standard input output.h, right? And we have also seen what is inside of this file, and those code gets copied into this source file, and this program will create an expanded source file called first.i, and that source file goes inside of the compilation phase or a compiler. Then the compiler generates an assembly code. As this process is based on the GCC compiler, so this phase is an extra phase for a debugging purpose, because the compiler actually generates the machine code directly, but in this it generates an assembling code, that has .s extension, and the foster s goes to the assembler that creates an object file. As I have mentioned earlier, that this printf function has the implementation in the standard library, not in the header file. And here the job of the linker is to find the actual implementation of this printf function in the standard library and combine it with other object file and create a whole new executable file, that is a.out. So basically linker actually combines different object files into one single executable file, so that it can be executed by the loader by keeping it in RAM. And this is how the build process works in C. And now we'll see inside of different files that are foster C, foster I, foster S, and so on. And to create this file during compilation phase, we'll have to write save teams and compile the file. And if you see inside of the proc directory, all the files are now created. So the foster C is our source file, and foster I is the expanded source file, foster S is assembly file, and foster O is the object file. And now if you see inside foster C, which is our source file, and there is no change inside of it. And now if you see inside of the expanded source file, let's see by using vim. It is of 873 lines, because every code inside of the header file has been copied to our source file, and it has been up to 873 lines. Our main code is from the line 3 to the return 0, right? And everything above of it is just a copied code from the header file. And now let's see foster.o file or foster.s file. And this is an assembly language file, because there has been the use of different registers and different assembly language instructions. This is just for debugging purposes for GCC compiler. This is an extra phase it does while compilation. And and now you can see foss.o, because this is an object file and you won't understand anything written inside of this file. There is just rubbish data, as this is the object file.